Good morning, everyone. Today we will be presenting our final project for our Intro to SOLIDWORKS class with Professor Bao. For this final project, we had to design a mechanism with at least 9 parts and include the technical drawing of the assembly along with a video of the mechanism in motion. For this, we decided to design a crude oil pump, which we thought it would be a fun yet challenging mechanism that would allow us to showcase the abilities learned throughout the entirety of this course. But first, we will begin by first introducing the members of this project. Due to the current situation we are all living, my partners cannot be here to present with me, so on their behalf I'll present them. Karina Urdaneta, majoring in mechanical engineering, she likes watching movies, reading books, and decorate interior spaces. My name, Maria Clementina Pablo, majoring in mechanical engineering, I like engaging in outdoor activities, especially running. And Andrea Urdaneta, also majoring in mechanical engineering, she's passionate about animals and likes spending time building puzzles, etc. Now, we first want to start by talking about what exactly is a crude oil pump and how it works. A crude oil pump is a machine used to extract liquid substances, in this case petroleum, from underground reservoirs. What's interesting about this machine is that the rod operates the oil pump in two stages. One stage occurs in the downstroke of the rod, as it is allowed to fall back into the well, while the other is called the upstroke, when the cranks pull the rod back up higher into the air. On the downstroke, all of which happens down at the reservoir and is not illustrated in our design, the valve closest to the surface, known as the riding valve, opens and allows the oil from the well to flood into the plunger holding chamber. On the upstroke, the riding valve is closed by the lower system, known as the standing valve, is open. This valve draws up new oil by a sudden low pressure environment created by the rising rod. At the same time, the oil caught in the plunger is forced to the surface where it exits and is collected. The force at which the oil can be expelled from the plunger is at what is called the fountain effect of spurting oil. Although this machine seems very complex from the arrangement of its parts to its very own operation, we feel it's important to highlight its origins and its different functions throughout history. In 2000 BC, Egyptians invent the shaduf to raise water. It uses a long suspended rod with a bucket at one end and a weight at the other. In 200 BC, a Greek inventor and mathematician invents the water organ, an air pump with valves on the bottom, a tank of water in between them, and a row of pipes on the top. This is the principal design that is now known as the reciprocating pump. In 1675, Sir Samuel Morland patents the packed plunger pump, capable of raising great quantities of water with far less proportional strength than a chain or other pump. In 1868, Stork Pumpen of Hengelo, Netherlands, pioneers the concrete volute pump of water drainage. In 1886, United Centrifugal Pumps is incorporated. It becomes the world's foremost supplier of high-pressure crude oil and refined product pipeline pumps. Okay, so we can slowly see how throughout history they make various arrangements and incorporate additional features in order to improve what was once a very primitive version of a pump and transform it into the machine that we now know and use today. Finally, we would like to discuss the different types of pumping systems, others being more modern and sophisticated than the one we elaborated for our project. Starting with the beam pumping, which is exactly the one we recreated. The beam pumping is the most common one, where the pump is kept below and on the surface to increase the pressure to pull the oil. A sucker rod pump is attached to these rods close to the bottom of the well in order to pull the oil from the resource found beneath the well to the surface. Next up is the hydraulic pump. This system is fitted with hydraulic down pump instead of a sucker rod that brings oil to the surface. The hydraulic pump are made of two pistons joined together by a rod. Subsurface and surface hydraulic pumps work together to bring the oil to the surface from the well. The surface pump sends the oil through the tubing string to the subsurface pump at the bottom of the tubing string. The oil is then sent to the surface through the second tubing string. And lastly, we have the electric submersible pump system. This system has a centrifugal pump in the reservoir. In this system, the pump is connected to a long electric motor that, with its several blades, the pump is able to move the oil within the well. An artificial lift is applied by moving the blades on a pump shaft that creates pressure on the surrounding oil, therefore forcing it into the surface. Now these are our sources where we got most of our information in our machine. So we hope you found our presentation interesting, and we leave you with a video showing the mechanism in motion, which is right here. And that was it. Thanks for watching and hope you liked it.